Hi, so welcome to my video. This is my response to creating a generic XML response parser for Cloudspokes. So I'm going to provide a quick overview of my solution to the problem. So I've created some metadata objects within Salesforce. I'm going to set up to kind of show you what I've built. We have a number of Apex classes, so there's the document mapping utilities, and then the supporting classes that you provided on your website, morder and morder line item. We've also got some objects, so the ones you're interested in are the component attribute map, component map, object attribute map, and object map. So basically, object map is the top level sort of entity, and the others are basically child entities. And what these do, if I go to the object map screen, select an example, is they map an XML document onto a Apex class. So let's give a bit of a description as to how it does that. So the top level object map basically specifies a source path within an XML document and the target Apex class. So this source string here, basically what it does is it provides the path to location in the XML document where I should be pulling out attributes related to the order class. The star symbol is basically a wildcard character, so it basically says match any first element. The / basically then says traverse to the child of that element. We have another star, so traverse again, and then find an element called sales order, followed by another child element called header. So if I relate that back to the XML that you provided, basically what it's done is it's traversed down from here through to data area, then it's looked for sales order, and then it's looked for the header. After that point, we then proceed to map each attribute, and each attribute's a bit like the object has a source and has a target. The target being the attribute within the Apex class. The source is relative to the source for the object. So as you can see, we're already at the header level, and then we traverse the tree again, looking for payment terms, user area, payment method, CC info, and account name. And basically what I've got in the Apex code is a method that traverses the XML hierarchy recursively. So you pass in the source string, that's broken up into an array, and then it compares each node in that array and basically makes sure that it either matches the name or matches a wildcard character. And it proceeds to continue searching down through that array until it finds the last element. And if it successfully finds the element, it returns it in this list collection called return nodes. It will match, it can return more than one node. So again, if we go back to the XML, so for instance there are multiple line items in here, so when I do a search for the line, it would return 2 nodes because it would find two places in the XML document where it matches. So let's go back again to the class. So here we can see it's mapping each of the attributes. There's also this target type, data type property I've got here, which I thought I was going to have to do something with this, with these values to basically convert the value held in the XML document to the class attribute, but actually, as you'll see in a moment, I'm using JSONs to do the conversion, and this actual attribute wasn't needed anymore because the JSON basically takes care of the conversion for you. The next level, so we've also got component maps. So what this does is it maps another, well, it maps a complex type within the XML document onto a component class. So line items is an attribute of morder that is actually based on the morder item class. You can specify the data type or data type collection for that component class. So in this case, it's a map, and you can also specify the attribute that should be used as the key for that map. If you were to select list or set from the target data type, then obviously component key is not necessary. If you drill down on the component map, then you can see likewise there's component attribute maps that basically define each of the attributes that needs to be taken from the line in the XML document and mapped to the line item object within the morder class. If I expand that, one other thing I'll quickly show is that most of the time you just map value contained within an element. So for instance, if I was to have a look at line order item description, you can see, for instance, slap chop is an example of a value that was pulled back. I've also added the ability to pull back the value from an attribute. So basically, if it traverses down to this element amount, this @ symbol denotes that it should actually pull the value from the attribute labeled currency rather than the element named amount. You can have multiple component maps if you need to. Although I haven't done it for this project here, I think it would be reasonably easy to sort of set up a hierarchy of component maps that you could essentially map a document to an object that was more than sort of 2 levels deep. What else is there to show? So within the actual object code itself, let's take a look at some of the functions. So I've got this run test built in, so basically this just provides a quick example of how to use the class. So basically all it does here is retrieves an object map, executes that object map using the XML document provided, and I've basically hard-coded the example that was on your website into this sample XML. Builds up a JSON representation of that class, and then deserializes it and casts it into the morder class to prove that it works. And then you can reserialize it and compare the before and after to make sure that it's basically providing the same thing. So I guess if I give a quick demo of that, so I'll open up my developer console. Loads. Execute. Success. debug log for here. So basically you can see it searching for each of the attributes. See that it's found a component map. It's using the map collection type. It's found 2 component nodes within the XML document. It proceeds to map those. You can see that it's getting an attribute for currency as opposed to the element value. And then if you scroll down to the bottom, you can basically see the JSON that it creates. And then the second one is basically we've cast it back into the mOrder class and then serialized the object again. So as you can see, the order of the attributes is slightly different, but essentially it is the same object. What else can I show you? So there's obviously a test class to go with this. So test utilities. So this basically contains all the setup for the object map that you saw in this demo. So if you need to recreate it, you should be able to pull the information from here, or likewise you can just use this to test the class. So probably do with a bit more exception handling in the main document mapping utilities. There's nothing really in here apart from a few asserts to make sure that the right parameters are being passed in, the right sort of functionality is happening. But yeah, given the time constraints, that's exception handling is one of the things I had to leave out. So there's no sort of custom exceptions thrown. For instance, the source paths that are entered into the object map don't work, then it can potentially throw an error, or it may just skip that attribute map. So I think that's basically the end of my presentation. I think it meets the criteria. Like I said, I think there's still room for improvement on it. But overall, I think it meets the requirements. So have a look and let me know what you think. Thanks.